Hi, this is Sung and I'm the Principal and Director of Sky Academy, and we have basically been going through trigonometric ratios, and we'll be going through trigonometric ratios and doing a couple of questions along the way. Now this episode is basically designed to catch up on all the theory, or now that we've caught up on all the theory, is to now go ahead and do some questions and that apply the theory that we've learned. So we've learned about right angle triangles having opposite, adjacent, and hypotenuse sides according to the right angle and the special angle, or the trig ratio angle. Okay. We've learnt that sine equals to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, tan is equal to opposite over adjacent. We've learnt that finding the sine, cos, and tan of an angle gives the ratio, and finding the inverse sine, cos, and tan of the ratio gives the angle. And you can only find the sine, cos, and tan of an angle, and you can only find the inverse sine, cos, and tan of a ratio. The other thing that we learnt was Pythagoras' theorem, but here's an opportunity for us to consolidate all the work that we've done and go through some of the basic kind of applications or working with the trig ratios. So for example, here we've got sine 17, okay? If we want to work out what sine 17 is equal to, we use our calculator. So I'm using a Casio FXAU plus 2, I think. All right, and this calculator is really helpful. I think it's the best one that you could use. That's out of the ones that you're allowed to use for the HSC, and I would highly recommend it. The Sharp calculators are really good too, but I just think that the Casio ones are really are in particularly user friendly. Alright, so let's use sine 17. So basically what you do is you go to the sine button in your calculator, which is in the second line of the function buttons, and it should be written as SIN. You should find it fairly simply. So you press sine and then you press 17, close brackets, and it gives you a ratio as a decimal. So you write that decimal up here. Now it's a massive long decimal, but I'm just going to write the first 3 digits, rounded to the first 3 digits. So it's 0.293, and I'm going to write 3dp, okay? Because it's rounded to the 3 decimal places. I'm going to do the same thing for cos, 24 degrees, 15 minutes and 30 seconds. And to do that, you press cos, which is next to the sine button, 24, and then there's a degrees, minutes and seconds button, which is kind of a couple of buttons left of the sine button, and you should see that fairly easily because it looks like degrees, minutes and seconds. So you press 24 degrees, minutes and seconds, 15 degrees, minutes and seconds, degrees, minutes and seconds, and you press 30 degrees, minutes and seconds, close your brackets, equals 2, and that should give you 0.91, and to 3 decimal places it's 12, even though you might have 11, but then the 7 after it means that you round it up to 2. So that's the 3dp. Okay, and then you do the same thing for tan 23 degrees 35 minutes. So tan 23 degrees, minutes, seconds, 35 degrees, minutes, seconds, close brackets, equals 2, and I get 0.436, but we round the 6 up to 7 because the number after it is 5, okay, to 3dp. Now the reason why I do it to 3dp is because I think with trig ratios in particular, one decimal place is not enough. 2 decimal places might be enough, but the 3rd decimal place just gives you that much more detail or that much more accuracy to your answer without compromising on efficiency of what the answer looks like. So 0.437 I think is a good way of expressing the answer. Now in this situation we're using the inverse sine, cos and tan. With the inverse sine or cos and tan, because your answer is going to be an angle, right? You can't leave it in decimal form. You've got to leave it in the form of degrees, minutes and seconds. Does that make sense? So let's do the first one. Inverse sine, you press shift and then sine, and then the fraction 5/17. Now I find the Casios make it a lot easier to work in fraction form than the sharp calculators do. But I've got here 17.1046 ... Now, that's a decimal, but we want our answer to be degrees, minutes and seconds. So what I do now is press the degrees, minutes and second button, and it converts it to 17 degrees, 6 minutes, and 17 seconds. Okay, and that will be our answer for that particular question. I'll do the same thing with the next two. So inverse cos of 0.657 close brackets equals 2, and this answer will be 48 degrees, 55 minutes, 43 seconds. And then the last one, which would be inverse tan of 3 close brackets, gives you 71 point something. Whoops. Which gives me an answer of 71 degrees, 33 minutes, and 54 seconds. Okay? So just check that you get similar answers for that. Okay? And that's how you do those sort of questions. When it comes to doing questions where you've got a triangle and you've got to work things out, let's have a look there. Okay? So you've got a right angle triangle that's 13, 5 and 12, and you've got to find theta, right? Well, what I would do is I would say that sine theta is equal to 5 on 12, right? So then theta is going to be equal to the inverse sine of 5 on 12. Does that make sense? Sorry, not 12. It should be 13. Alright. And thank you at home for picking up that mistake. Okay? Because 5 on 13 is the opposite over hypotenuse, which is sine. Sine is opposite over hypotenuse. So, let's work that out. And I've got 26.61 whatever, and in degrees, minutes and seconds, it's 22 degrees, 37 minutes to the nearest minute, okay? Right. Whereas these ones work to the nearest second. So these ones here, this answer here would be 22 degrees and 37 minutes. Okay? Now, with this one here, you've been given the degrees and you've got to work out B and C or A and C. And you've got the hypotenuse. Now, so sine of 30 degrees is going to be equal to BC on 20. Yep. And you also got that cos of 30 is going to be AC on 20. And the reason why is because opposite over hypotenuse is BC over 20, and that gives you sine of 30. Adjacent over hypotenuse is cos of 30 gives you A on C. And then it's just a matter of figuring that out. So you've got 20 sine 30 degrees equals to BC, and 20 cos 30 equals to AC. BC, if you put that on your calculator, should be equal to 10, and the reason why I know is because in the next chapter we will learn that sine 30 is actually equal to a half. Alright, so half of 20 is 10, and then for this one, let's work it out. AC is equal to 17.320 to 3 decimal places. Alright? Yep. Okay. So, this should all be familiar junior maths stuff, but if it's not, then then this is a good example of the sort of trigonometry that you might be asked to do in an exam, okay? And we will certainly be building on this in future lessons. So go away and review this stuff and practice a lot of questions on it. But in the meantime, thank you very much for watching.